These are all 6J6 twin triode tubes. So 2 triodes, that would be 6 connections. 2 plates, 2 grids, 2 cathodes. And 2 more connections, because it's an indirectly heated cathode, all jammed into a 7-pin socket. But look what they did. It's twin triodes, except each triode section shares a common cathode. So we can use pins 3 and 5 to heat the filament, pin 7 for the cathode. Then we can bring out the 2 remaining grids and the 2 remaining plates. U.S. Army, Navy. So they're manufactured during World War II. Take a look at this one. U.S. Navy. So it says manufactured by RCA. And sure enough, it indicates manufactured by RCA. You can see how the top half of the glass is blackened. That's because the getter is located up there. But it was manufactured for Western Electric. So Western Electric got the contract, RCA manufactured and branded the tubes, manufactured by RCA under a General Electric contract for the Navy. Don't see this name much anymore, Wells Gardner. Tube has a U.S. Navy ensign, and it was made by Slovenia. Smart Slovenia. A very popular TV front end tube. This particular layout was so popular that Western Electric manufactured a completely symmetrical tube in this configuration. This tube was marketed under 2 different names. They're identical. This is a 4CX250B. It's darkened here because the box was water damaged. Now this tube came out in 1960. Although its predecessor, the 4X250B, was around probably in 53 or 52. Collins Radio came out with a AM transmitter for amateur service that had the 4X250Bs in 1955. The difference is the 4X250, this is made out of glass, and this is made out of glass. The C stands for ceramic. I don't believe I ever worked on a transmitter that made 400 watts, but these things would do 250 watts all day for 5 years. The connections to this tube were a little bit interesting. The plate is this metallic mass right here, referred to as the radiator. I should back up a little bit and say these tubes would be mounted in a socket, of course, but with a glass chimney with forced air cooling blowing across them. They work horizontally. Most are installed vertically, in my experience. The blower is located below the socket, blows air upward into this annular groove here. Then the air escapes and travels up. All of this is radiating surface. The glass fits rather snug so that the most of the air goes through this. See that? If you lose a fan, you lose a tube. Anyway, this is the plate, or the high voltage positive connection to the vacuum tube. The cathode, which is heated hot, coated with probably thorium or some other electron emitting metal, is connected to pins 4, 2, 8, and 6 down here. This grid, it's connected to a high positive voltage, not as high as the plate, but close. It's connected to this ring. The control grid is connected to this index pin. And then the heater that provides heat for the cathode is hooked between 3 and 6. And you can see that pin 1 is connected to grid 2 by virtue of this link here. So this is not a simple socket. Makes connection here to a bunch of pins here, and then separately here. Plus having to manage airflow. For the most part, if you did not overdrive the grid, and if you kept the filament at 6.0 or less, any higher you would ruin the emissivity enhancer on the cathode. Common practice was to run them below 6.0. Run right, these are very, very dependable tubes. They were first introduced by a company called Edel-McCulloch, and that was shortened to EMIC, which was their name for years and years. And then it was bought by Varian sometime.